Yeah. Yes. So after semi-integrated, we have automated cell, which is fully automated and integrated with the material handling systems, and in which there are two types. One is flexible manufacturing cell and flexible manufacturing system. So depends on the size, it may vary. For if you are selling, if you are telling the name cell, that implies the a lower space or within less space. Whereas the manufacturing system, we can say, it consists of number of material handling system with multiple machines which can manufacture that. Yeah, coming to machine cell with the manual handling, here you can see a U-shaped manufacturing system or a machine cell system where the work-in is coming out here at the entrance and going through the production manual or production man who is working over here, and next in a sequential order it is going through the man to the other man, and there are in between we are having the material handling system which can transport that particular material or element from or the particular specimen workspace from one another, and in a sequential order after doing or completing one process it is going and it is coming and in the other process. So normally this we call as U-shaped machine shell with the manufacturing or material handling systems which are arranged in between that particular manufacturing machines. Next to this, we have cell with semi-integrated handling, where we have the mechanical or mechanized work handling, including with the production mans, which are aiding or uh, helping the particular mechanized or automated work handling systems over here, which is you can consider this as a belt running over the taking the particular elements, and after completing that particular manufacturing systems or operation, the belt will be moving, and accordingly that particular metal handling will be taking place by the mechanized work handling systems. Over here we can see as taking an example of belt drives. So that in that way it will complete the work by taking in over here and coming out over here after completing all these manufacturing operations. And and these we call as like inline layout. This particular example what we are seeing here is nothing but an inline layout with mechanized work handling between the machines. And next to this we have cell with the semi integrated handling. So as you know, the name implies it's integrated with the particular automatic system with some of manual workers, where the mechanized work handling system will be circling in a loop or a cycle, and the number of process or the elements or the workpieces will be kept input over here, and which will be moving along this particular cycle of operations, and this can be operated sequentially or in a loop layout in such a way that the variations also for part routing between the machines will be managed. And even rectangular layout also allows variations in part routing and allows the return of work carriers if they are used. So this is a fourth type where the part moves in mixed model production systems. So the first one, as you can see here, we can repeat the particular operation, and from that it will concentrate morely it's like variation managed by operating different moves. So in this the part will be mixed, like kind of, which can be operated, the if you can see here, the repeat operation can be done in the first mission itself, and from that first mission again, like if we go to second mission will be backtracking move. So after particular missioning operation it can be coming to the first one. So it is not having any kind of fixed particular mode of operation. It is mixed, and it can be varied from one another in any different manner. As you can see here, this will be sequential move. So after second operation it should go to the third operation, and by bypassing this particular third mission it will be moving for the fourth one. So it is like kind of a mixed here and there. It is not following any structure or systematic procedure, so that we call as like mixed model production system. So this is a flexible manufacturing system combinedly. As you can see, it's in a closed loop cycle where the different machines or CNC lathe is there, CNC milling machine is there, a 6-axis robot is there, like for operating any manufactured element or part, And again, coming over here, we have an AGV, automated guided vehicle. So in the previous example, I just quoted an example of belt drive. So in that place of belt drive, we are using this AGV, which will follow this particular line, which won't deviate from this particular line, a green and yellow bordered line. So it will move along that, and whatever the process or the material need to be processed will keep on this particular machine, and it will go on to each and every mission in a sequential or non-sequential order, depends on the requirement, and it will complete the particular work. And here you can see this is automated storage at retrieval system, where the material will be, or the material requirement which needs that particular thing will be stored over here, and which can be retrieved also once the machining process is done from this particular AGV. So AGV is the one which is rotating or traveling through loop, and which contains, this is a flexible manufacturing system where different operations can be operated in one single setup in a system or a machine cell. So this like FMS is nothing but a group of processing workstations which are interconnected by means of an automated material handling system. So in this case, just before we have discussed taking an example of AGV. So in the same way, we can have an example of the belt drive also, and even we have storage system once for inputting that particular material to be manufactured, or after completing that particular manufacturing process, it will be taken and it will be stored in an storage system. And all these processes or procedures will be controlled by the computer control system or integrated computer control system, which is nothing but all these particular systems which are operated are centrally controlled by a computer or computer system. So normally this is very useful in mass production or any typical industrial equipments. So basically we have these four components of flexible manufacturing system. One is the workstations, as you already saw. The workstations are the one which we have a number of machines with the equipped machinery or the particular requirements which are useful for doing manufacturing process and all. So next to that, we have automated material handling system and storage. As I explained before, it is the one which gives the input to the material which is going to operation of at different machines or manufacturing process, and again it will be handling the material which will be automated, because AGV is the one of its kind which we should quote over this particular scenario. And we have computer control system also, which gives the centralized control over each and every machine component in the flexible FMS system. And even along with this, there is an integrated working sequential process with the manual labor. So manual labor is also important for synchronizing the work which is carried out with the FMS system. So there are basically types of SMS system, three types, distinguished along the number of machines, depends on the number of machines which is present in the FMS. One is single machine, the other is flexible manufacturing cell, and then flexible manufacturing system. So depends on the number of systems present in the particular system, it is these particular classification is happened. So as you can see, the single cell, it is nothing but the name implies, it will have one particular storage or machining process CNC center where you can do task one at a time. So it is periodically, it is a sequential one. So after completing one, the other will be loaded and the completed one will be unloaded. So this is one kind of operations where you are going to operate using a single machine. So normally this particular kind of equipment we call as a single machine cell. So next to it we have manufacturing, a flexible manufacturing cell, just increasing two more, like two or three workstations, or normally workstations are nothing but the CNC machines what we are using. So normally if two or three CNC machines are there, and we have processing station with this particular individual CNC machine. So that particular stations or workstations are useful for doing the respective operations which are they intended to do. So in the same way, we will have loading and unloading stations for this particular workstations. As the number increase from 1 to 3 over here, the like complexity or the rapidity of manufacturing is more, and the like the production wise is also, it is very effective. In the same way, the flexible, that is for the previous is for flexible manufacturing cell. So if it is coming for flexible manufacturing system, we have n number of like 4 or more components or machines or workstations for processing, which are connected centrally to a mechanical part handling system and electronic distributed computer control or computer system, where it is operating through computer through making this particular system. These kind of systems you can see mostly in highly complex or mass production industrial processes. Like one example you can take of car manufacturing system. So that particular system, you can see the robots will be painting a car, and even the belt canvas will be moving one part to the other. So all these operations will be either be complex, but it is a very like operated in a very systematic way, one after the other, and even we are producing the mass production in an effective way. So that particular scenario, we call this as a flexible manufacturing system. So this is like some distinguished characters. So as you can see, the number here over, we can say this is single mission cell because we are having only one, the number of missions. And if it is 2 or 3, then we call as a flexible manufacturing cell. And if it is more than that, then we call as flexible manufacturing system, which we have seen the earlier slide. So for this, the increase like with the increase in the number of thing, and there will be increase in the investment, production rate and annual volume also. So based on the investment and the production rate what we are getting for that particular cell will be increased by increasing in the number of machines, as you can see in this particular graph with the, which are reflected or represented here in a square waves. So as you can see, this is like flexibility criteria applied to 3 types of manufacturing cells and systems over here. One is like single mission cell. This is self-explanatory. You can see. Only thing here, the simultaneous operation will not happen in single mission because it is having only one. Whereas other two, which is flexible manufacturing cell and FMS, in this both it can have the simultaneous production of different parts. Whereas in single cell it won't happen. And even in error recovery, if any breakdown has happened, the recovery time will be limited, like due to only one mission in single mission. But in the case of the other two, the recovery very like is limited for very few in FMC, which is flexible manufacturing cell, because there are 2 or 3. So if one can be redundant, and if some mission will be breakdown, the other two will be working. So in that way they are going to manage the error recovery. Whereas the like flexible manufacturing system, we have the mission redundancy. Redundancy is nothing but the spare thing. So we will make some missions on at spare redundant and minimize the effect of breakdown. Even if the breakdowns happen, we can effectively continue the operations without any chaos or complexity. So these are the types of flexible manufacturing layouts. As the diagram you can see, this is the line type. Starting from the point over here, the man will be loading here, and here the mission automation and the second mission automation. So the workflow, this is the part transport system. So in the case, the previous case, this can be an AGV or belt conveyor, or like belt conveyor, or else like chain whatsoever, like depends on the requirement. You can choose this particular part transport system. And here you can see partially completed the particular work part, and unloading will happen here. The loading of that particular loading manual will be loading that parts, and here unloading will be unloading, sorry, unloading manager will be unloading over here. And here we can see the completed parts. So here after completed parts, this is another one, like where the loading and unloading is taking place at the same way. So here this is the line 1, and here the workflow can be done. This is going over here and again coming back after completing the part. So starting and completed parts will be collected at the same thing, but which is moving in a line format over here. So coming over here, completing over here, going back over here. So this is the loop type. We already explained how the loop type will work. Starting over here, it will complete different operations over here, and the direction will get over here, and depends on the requirement. Suppose like if it is a milling mission, it should be milled if the part is required to have that particular milling operation. The same way, if for drilling or tapping or different operations, we can't restrict that particular part should go each and every machine part. So as depends on the requirement, we will put that particular routing to that element, and according to that routing which is given to it, it will continue that process, and it will complete its production, it will complete its operation of manufacturing, and it will get or come to this unloading and get that particular completed parts out. So that is the basic theme and of this particular FMS, and this is the loop type as we already discussed, and this is the ladder type. As you can see, everything is in the structure of ladder. So the part will enter over here, it will go come over here, in the same way it will go come over here, it will check, and after completing that it will go in this way. So if it is having a requirement, first it will enter here. If it is not having, it will check over here for this. Even if it is not having over here also, it will, so in that way it will move and it will come back. So it's basically depends on the shape of that particular movement of the part which is located. And here also you can see the parts input and the part collecting will be like, in the sense, loading and unloading L or UL is in the same place. So here you can see the open field type. The loading and unloading station is typically located at the same end as we see earlier, and the parts will go through the substations. So here we can see the substations, which are nothing but the CNC machines or coordinate measuring machines, and with the help of AGVs from one substation to other. So this is one substation. So with the help of AGV, from here to here they will move, and from here to here they will move, and this is a path through which the AGV or else like the automated guided vehicles can move for inspecting or for moving from one substation to another, which is nothing but one workstation to another, that is CNC machine. And after completing it through the help of AGV, it will come to the same point for giving out or unloading the like final part. And robot center type, as you can see here, the robot will be operating by taking the parts which is the like element input over here, and it will place on the work table of machine respective machines, and after completing, the robot manipulator with the end effector will place it and it will finish the process. So these are the basic benefits of like, as you know, it is having a lower manufacturing lead times because we are avoiding the manual labor over here. Definitely the lead times will be very less, and it is for higher machine utilization. The production rate and the contribution is very high, and as and when compared to the conventional machine shop. And here we are having the greater flexibility of production scheduling, like based on the requirement of the part element. Without any chaos, we can like use effectively the each and every mission with the process route. So that is the main advantage of this particular FMS. And we have this bottleneck model where like in the starting step of FMS, we have a scenario of using only one where the like all together like will be depending on that particular one machining process, where after doing that process only the remaining process will be done. So that particular situation we call it as a bottleneck situation or bottleneck model, where the rough estimates of system parameters, production rate, capacity utilization or be like estimated, and overestimate system performance. All these taking into this consideration, we will see how it will work. So there is like let me explain this in the next video. Thank you.